Okay, students, now let's do one more problem on this NK linear block code. Okay, so here the reason I'm doing this question is because this question is slightly different. Okay, not that much different. All you need to do is like I said, they'll give us in the form of G or P or H. Okay, here also they have given the form of P, but if you read this question, you won't be able to understand immediately. Just read the question, you will understand. Here they're written the parity check bits of an 8-4 block code are given by. So they have already mentioned is the parity check bits. You see, so this is the equation C5, C6, C7, C8. The parity check bits of 8-4 block code are given by C5 is equal to D1 plus D2 plus D4, C6 is D1 plus D2 plus D3, C7 is D1 plus D3 plus D4, C8 is D2 plus D3 plus D4. So what is D1, D2, D3, D4? Those are the message bits. So here instead of U and V, they have used C and D. That's all. That's the only difference. Okay. The rest of this question is the same. Find the generator matrix and the parity check matrix. Find the minimum weight of this code. Find the error detecting and correcting capability of this code. Construct an encoder and the syndrome circuit of this code. That is the question. So here this is pretty straightforward, right? They have given C5, C6, C7 and C8, which means they have already given the equation of, you see, C5, C6, C7, C8. So but this is how many? 8, right? This is an 8-4 block. So they have already given the last 4. So what about the first 4? Of course, we all know what the first 4 is. The first 4 is like this. That is C1 is equal to D1, C2 is equal to D2, C3 is equal to D3, C4 is equal to D4. Okay, this is the question. This is easily understood. So C5 is given in the question, D1 plus D2 plus D4. C6 is actually D1 plus D2 plus D3. C7 is equal to D1 plus D3 plus D4, and C8 is equal to D2 plus D3 plus D4. See, these are the bits. So they have, that's what they're saying. So actually this question is a little bit of tricky, not confusing, it's tricky, because here what they did is they basically gave the equation of P. They have actually given the matrix of P in this question. That's what you need to understand. P, that is P is equal to D1, D2, D4. That is 1, 1, 0, 1. D1, D2, D3. 1, 1, 1, 0. D1, D3, D4. 1, 0, 1, 1. And D2, D3, D4. 0, 1, 1, 1. See? This is what they actually gave. This is actually what they have given over here. Okay, that's the only difference. The rest of the procedure is the same. So what is the equation for G? G is nothing but IKP. And what is IK? IK is 4. So therefore 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, and the rest is P. 1 1 1 0 1 1 0 1 0 1 1 1 1 0 1 1. See, now I found the value of G. Now what is the value of H? H is nothing but P transpose I n minus K. So H is equal to P transpose I n minus K, which is P transpose I3. I4, I'm sorry, it's I4, right? Because 8 minus 4 is 4. So it is I4. So therefore, now let's write the answer. This is the answer. That is P transpose is transpose of this, which is 1101, 1101, 1110, 1110, 1011, 1011, and 0111, 0111. So this is P transpose, and this is I4 1000 0100 0010 So this is the equation for H. There, that's it, complete. So that I found that. Now next is finding the minimum weight. You don't have to find, so you know, in the previous problem you found the minimum weight because you calculated all the code vectors. We don't have that much time. That will take so much time. In the previous video you've seen calculating the code vectors took a lot of time, right? Even though it is easy procedure, it took a lot of time. So you're not going to do that over here. So what you're going to do is you're going to find the value of the minimum. You're going to find the value of the minimum weight by simply looking at the column of the H and what should be the value so that they become 0. Which all columns you can take the sum so that you will get a 0 sum. I can add, let me see, if I add 1 2 3 4, if I add these 4 I will get 0 column. If I add these 4 columns, I will get 0 column. Is there any other choice? Can I make it reduce down to 3? Let me see. 1. Yeah. this one, this one, this one, and this one. Nope. Since still you need 4 columns. Is there any way you need using 3 columns? Let me see. I'm looking for that answer. 3 columns. Nope. 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 Sorry. There's no 3 columns, which means 4 columns, right? So you need at least 4 columns to get a 0 column, right? What about this one? Nope. What about this one, this one, this one? No. Okay. When you're watching this video, if you can find a column, if you can find 3 columns in which if you add all of them, if you get 0, then that's the odd. Then the minimum distance is 3, or the minimum weight is 3. Here I can find only 4 columns. Which are those 4 columns? 1, 0, 1, 1. Okay. Sorry. 1, 0, 1, 1. And then if I take 1, 0, 0, 0. And then if I take 0, 1, 0, and if I take 0, 0, 0, 1, see, if I add these 4 columns, I will get all zeros. 1 plus 1 is 0, 0 plus all zeros, 1 plus 1 is 0, and 1 plus 1 is 0. See, so if I add these 4 columns only, I will get this. So therefore minimum weight is equal to 4. Okay. If you only write the reason, that is, it requires, you can say that it requires 4 columns, at least 4 columns of H matrix to get all 0. It requires 4 columns of H. That's why, therefore, the minimum weight is equal to 4. So I found the minimum weight. Now what is the other question? Next question is, they have asked is to find what? Is to find the error detecting and error correcting capability. Okay, this is B part. So C part, they ask you to find the error detecting and correcting capability. Since the minimum weight is 4, then minimum distance is also equal to 4. Because the minimum distance of an NK linear block code is the minimum weight itself. So D min is also equal to 4. So what is the error detecting capability means? The circuit can, or this circuit can detect up to D min minus 1, which is equal to 4 minus 1, which is equal to 3 bits. So the error detecting capability of this code is 3 bits. Okay, D min minus 1 is the error detecting capability, and this is 3 bits. Okay, now error correcting capability, T is equal to D min minus 1 by 2, which is, here is 3, so it is 3 minus 1 by 2, which is equal to, no, sorry, it's 4, right? It's 4. So 4 minus 1 by 2, 4 minus 1 by 2 is 3 by 2, which is nothing but 1, because it should be less than this, right? So it should be less than this, 1.5. So take the next integer less than that, which is 1. Right, that's what the equation is. It should be T should be less than or equal to D min minus 2. So 3 by 2 is 1.5. So you should take the next integer below that, which is 1. So 1 bit. So this circuit is able to correct 1 bit. Okay, that's the equation. Now the last equation is finding the, or implementing the encoder and the syndrome circuit. Encoder, all of you know how to draw, right? The encoder, let me draw the encoder. It requires a commutator, and it has a this is 8-4, so you need a 4-bit shift register. Okay, this is here the names are different, right? Instead of U and B, you have C and D. So this is D1, this is D1, D2, D3, D4, and here it is C1, C2, C3, C4, C5, C6, C7, C8. Okay, this is the circuit. This is the encoder of the circuit. So you know the equation for C1. C1 is equal to D1. C2 is equal to D2. C3 is equal to D3. And this is D4. C4 is equal to D4. Now equation for C5. What is the equation for C5? D1, D2, D1 plus D2 plus D3 plus D4. It is D1 plus D2 plus D1 plus D2 plus D4. This is the equation for C5. What is the equation for C6? D1, D2, D3. C6. D1 plus D2 plus D3 is C6. It's over here, okay. And what about C7? It is D1, D3, D4. I'm going to take D1. I'm going to take D3. And I'm going to take D4 and give them all in XOR gate. This is the equation for C7. And what is the equation for C8? C8, the equation for C8 is D2 plus D3 plus D4. D2 plus D3 plus D4. Okay. It's always better you draw very neatly, not like this. Okay, just draw it in you can draw it any way you want, but make sure that the equations are correct, so that therefore the circuit will be correct, and try to make it, draw it legibly also. Okay, not like this. This I am drawing it due to lack of space. Okay, so this is the equation for encoder. Now what about the other one? Is they have asked the syndrome circuit. They did not ask the decoder. They have asked only to draw the syndrome circuit, only a small part of the circuit. So let's draw that. So that is the equation is what? That is S is equal to RH transpose. What is S? Here 8 minus 4 is equal to 4. So S is S1, S2, S3, S4. This is the equation for S is equal to, and what is what R? R1, R2, R3, R4, R5, R6, R7, R8. And H transpose. We already know what is H, right? This is H. So H transpose is 1110, 1101, 0111, 1011, 1000, 0100, 0010, 0001. So this is H transpose. Okay, that's it. So what is the equation for S1? The equation for S1 is R1 plus R2 plus R1, R2, R3, R4 and R5. R1 plus R2 plus R4 plus R5. This is the equation for S1. What is the equation for S2? S2 multiplied with the second column, you will get R1 plus R2 plus R3, R1, R2, R3, R4, R5, R6 plus R6. Okay. What is the equation for S3? S3 is R1 plus R3 plus R4 plus R7. And what is the equation for S4? It is R2 plus R3 plus R4 plus R8. Plus R8. So this is the equation for the syndrome. So now all you have to do is simply draw the circuit. That is, first you draw the syndrome. So first you draw the 8-bit shift register. R1, R2, R3, R4, R5, R6, R7. This should be R8. R1, R2, R3, R4, R5, R6, R7, R8. Okay, you don't need this box. Okay, this box is not required. So first I will draw the equation for, this is the equation for S1, this is the equation for S2, this is the equation for S3, this is the equation for S4. So what is the equation of S1? It is R1, R2. Let me draw that. This is R1, R1, R2, there you go, R4, there you go, R1, R2, R4 and R5. Okay, R5. This is the equation for S1. What is the equation for S2? This is S2. S2 is R1, again R1, R1, R2. So this is R2, R3. So this is R3, R6. So I'll draw R6. This is R6. So this is the equation for S2. Now what is the equation for S3? R1 again, R1, R1, R3, R3, R4, R4, and you have R7. sorry, so you got S3. Okay, next is S4. S4 you have R2. R2 you have R3. You have R4. And you have R8. R8, I'll bring it over here. There. This is R8. So this is the syndrome decoding circuit. They didn't ask us to draw the actual decoder. So they just asked only for the syndrome circuit. So this is the syndrome circuit. Okay. So this is how we do the problem. Okay.